Okay, now let's see about XML schemas. XML schemas actually validate an XML document. XML schema defines the list of elements and attributes that can be used by an XML document. It also specifies the order in which these elements appear in an XML document and their data type. Microsoft developed an XML schema definition language to define the schema. This is also known as XML schema definition. We actually use .xsd extension for XML schema documents. There are actually two types in XML schemas, simple and complex elements. Simple elements are nothing but they does not contain any child elements or attributes. Their syntax is as simple as it just follows XSD element name and the data type. Actually, simple element contains content. Now let's see a piece of code about simple element. Look at here. Here the product data contains only element name and the type of the data it contains. Now coming to complex element. Complex element contains elements, attributes, and mixed content. The syntax for complex data type is as follows. It has data type name and the model declaration. Examples for complex data type element. Here is the code for complex data type. There are few questions about this XML schema. What is an XML schema? XML schema gives the definition of an XML document and it has the following. It has elements, attributes. Elements are the child elements, order of child elements, data type of each element and attribute. What is a simple element? Simple element contains only text and following some kinds of elements. It does not contain attribute. It does not contain other elements. It cannot be empty. What is a complex element? Complex element contains other elements or attributes and the following are kinds of complex elements. It can have empty elements. It can contain other elements. It can only contains text. It contains both other elements and text.
Attributes and restrictions in XML schemas. Attributes in an XML schema. An attribute in XML provides some extra information about an element. For example, if we have an element in an XML document, which is a string and it displays some message, an attribute can give information about what language that message is in or what type of that particular message is. So an attribute gives more precise information about an element and generally makes it easier for us to understand that particular element in an XML document. An attribute is generally present in a complex type element. As we have seen that a complex type element is that element which defines more simple type of elements within it. So an attribute is generally defined for a complex type element. So attributes are defined within an XML schema having two properties, name and type. Here the name means the name of that particular attribute in the XML document and the type is nothing but the data type of that particular attribute. The syntax for an XML schema attribute is as shown. Here we have an example. Here is an element whose name is name and it has an attribute lang, which means language, and its value is set to en, which means English. So corresponding to this attribute lang, its definition in the XML schema is as shown below. Here the name is set to lang and the type is the data type of lang, which is string. So this is how you define an attribute in an XML schema. Default and fixed values of attributes. So an attribute can have a default value or a fixed value. A default value is automatically assigned to the attribute when no other value is specified. It means that when person who's writing the XML document doesn't specify or give a particular value to that attribute, this default value, which is defined in the XML schema, is given to that attribute. So in order to give a default value to an attribute, we use a default option and we give a particular value in the definition of the attribute. In some cases, you want a fixed value such that whatever the user gives, it should not change, and only this fixed value can be used as that attribute's value. For this, we use the fixed option and we set it to a value. So this is how we use default and fixed attributes in an XML schema. Now coming to optional and required attributes. Attributes are optional by default, which means that attributes are generally not needed in an XML document. It isn't mandatory, but we use it to enhance the information of an element. So sometimes in some scenarios, when you want to specify to the person writing the XML document that this particular attribute is mandatory, we use the use attribute and set its value to required in order to tell that this particular attribute should be there in that particular XML document. So this is how we define a required attribute. Restrictions in an XML schema. Restrictions are used to define acceptable values for XML elements or attributes. Restrictions on XML elements are called facets. Generally, if you want to restrict a value of an element, like you don't want the name to be an integer and you don't want the marks to be a string, so that is when we use restrictions, or you want to set it to a particular range of values or a set of values, or you want it to be a particular length or a particular pattern. This is when we use restrictions on either attributes and elements in an XML schema. So the syntax of a restriction is as follows. Here, the base is equal to element type means that the element type is nothing but the data type on which the restriction is being imposed, and the restrictions between the opening tag and the closing tag can be a number of functions that can be applied on that particular element. For example, here the base is equal to access colon integer, which means that this particular restriction is specific to an element of a type integer. Here we have an example which defines a restriction on an element called age. The restriction is that the value of the age cannot be lower than 18 or greater than 100. So this is how we define the restriction. We first give the element's name, and then we define what type, like is it simple type or a complex type, and then we give the data type on which the restriction is being imposed, and then to limit this particular element within that range, we use the min inclusive and max inclusive restrictions. Here the min inclusive means the minimum inclusive value and the max inclusive means the maximum inclusive value. So we set these values to 18 and 100, which means that the age is restricted between only 18 and 100, which means that this element's value can only be between these two numbers with these two numbers included. So this is how you restrict a element within a particular range. The next example shows how you can restrict an element to a particular set of values. Here we have an element grade, and we only wanted to accept 3 grades, A or B or C. So we use the enumeration restriction and give the grade values as A and B and C. So only these 3 values can be taken by this element. So this is how you restrict an element to this particular set of values. So there are many restrictions that can be used on the data types. Here the enumeration as shown is define a list of acceptable values. The length specifies a number of characters. The max exclusive, max inclusive, min exclusive, and min inclusive functions are used to restrict that particular element within a range. Here the pattern defines the pattern of a particular element. For example, if we want that element to start with 2 alphabets or with numbers, the third character being a number or an alphabet, we can vary it by using the pattern restriction. The total digit restriction specifies the exact number of digits allowed for that particular integer value. Here the white spaces specify how white spaces in that particular element or attributes should be controlled, like whether we should remove them or whether we should modify them or whether we can add them. The max length specifies the maximum number of characters that are allowed for that element, and the fraction digit restriction specifies the maximum number of decimal places allowed. So these are the various restrictions that can be imposed on elements and attributes in an XML schema. Thank you.
Hi everyone, now let's discuss about document object model. We generally call it as DOM. It is a cross-platform and language-independent interface that treats an XML or HTML document as a tree structure, wherein each node is an object representing the part of the document. The DOM represents a document with logical tree. Uh, Now let's see about XML document. XML document object model class is an in-memory representation of an XML document. The DOM allows you to programmatically read, manipulate, and modify the document. XML reader class also reads XML. However, it provides non-cached forward-only read-only access to the document. This means that there is no capabilities to edit the values of an attribute or content of an element, or it do not have the ability to insert or remove nodes with the XML reader. Editing is the primary function of the document object model. It is common and structured way that the XML data is represented in the memory. Although actual XML data is stored in a linear fashion when in a file or coming in form of an object. Notes in the document object model. In DOM, all parts of documents such as elements, attributes, text are organized in an hierarchical tree structure consisting of parent and children nodes. These individual parts of the document are known as nodes. Uh, Go through this example. Uh, this is the representation of a DOM. It is a hierarchical structure. Now let's see the properties of each node. Here, now let's see about the Windows object. It is always in the top of the hierarchy. The document object, when an HTML document is loaded into a window, it becomes a document object. Here comes link, form, and anchor. Now let's see about form object. It is used to represent form tags, whereas link object is used to represent link tags. Anchor object, we generally refer links, reference tags in this anchor object. Now from form, there are text area, checkbox, radio, select, reset, buttons. Here, these are the buttons that are available in form check elements. The methods used in DOM are write, get element by ID, get elements by name, get elements by tag name, get elements by class name. Uh, for write, we write a string into the document. To get an element by ID, we just give, it just returns the ID value. For getting an element by name, it returns the element of the given name. It returns the tag if we give the tag element, and so on. Now let's see about advantages of DOM. This file is passed only once. High navigation abilities. This is the aim of the DOM design. Language and platform independent. It is traversable, move back and forth in data. It is editable and dynamic. Now let's see the disadvantages of DOM. It requires more memory since XML tree is in memory. Operation speed is slower than compared to SACs. The uses of DOM are many and varied, but if we were to make list of the key abilities, these would include, first of all, locating elements in the document by ID, class, tag name, and other characteristics. adding and removing, modifying the HTML elements by themselves, modifying any attribute of an HTML element, such as their class, style attributes, and others. We can even use JavaScript to add animation to the present document by gradually changing the element's position on the page over time. Now, these are some few questions about DOM.